Okay, so that was for when n equals 1. We did psi n equal to 1. That corresponds to the first fundamental wave. One amplitude. Right? How many nodes do I have here? 2 nodes. Well, what if I go to the second fundamental wave? The second fundamental wave would be n equal to 2. How many nodes do I have with the second fundamental wave? 3, right? A node is where the amplitude is 0. So when I draw my graph, we're going to end up with 3 nodes eventually. So let's draw this graph. And it looks like this. It goes below the x-axis. Again, the x-axis is the distance from the nucleus. Now the y-axis is our probability of finding the electron. This part of the graph has positive values. This part of the graph has negative values. What happens when you square negative numbers? They become positive. So then this graph looks like this. The first hump is at 0.55 angstroms. The second hump is at 2.3 angstroms. This because when I graph this, this is the equation for n equal to 1. This is the equation for n equal to 2. When I graph that equation, that's what the graph looks like. Schrodinger model is a mathematical model.
I know, but if that equation is just for the graph, how do you make the numbers like
The numbers, it's kind of like this, okay? If my y value is 4, what's x?
16?
0. Got to subtract it over there. Or if my y value is 2, you can find what these values are from the equations. So that's where you can find the peaks. That probability is 5%, and that peak is 19%. So we have 2 peaks. Where is the probability 0? Here, here, and out at infinity. How many nodes? 1, 2, 3. So we have 3 places of 0 probability. When we did n equal to 1, one hump was 1 sphere. Now we've got 2 humps. So what do you think that thing's gonna look like? A sphere within a sphere. And I'm gonna draw it on the chalkboard because it's easier to do that.